Oh, you're my best friend. 12.3, pyramids and cones. All right, we're moving on to two new shapes. All right, let's first take a look at pyramids and all of its parts. There it is. It is called the base. The very bottom of the pyramid is called the base. On the very side, we call that an edge. And this one is kind of important. This is if you were to be at the very top and slide down the middle of the side. That would be called the slant height. And then if you were hanging from the middle straight down towards the middle of the base, that is called the height, so the regular height. All right, and so we have different types of pyramids too. We just worked with a square pyramid because the base is square. The one on the right side is a pentagonal pyramid because the base is a pentagon. So these pyramids have different names to them based on what type of base they have. All right, so here are the formulas for lateral area and surface area of pyramids. The LA, of course, stands for lateral area. The P is the perimeter of the base, so the distance all the way around the base. And then the fancy L, this one's important. It is called the slant height. It's the one where if you were to sit at the top and then slide down the middle of the side, the slant height. Okay, so that's important. Surface area. The big B is the area of the base, so you have to find the area of the base. And then if you notice the 1/2 PL, that is the exact same thing as the lateral part. All right, let's do some examples. Find the lateral area and surface area of this square pyramid. All right, here we have the formula for lateral area. Formula for lateral area, 1/2 perimeter of the base times the slant height. The perimeter of the base is just 6 plus 6 plus 6 plus 6, that's 24, and the slant height is 4. Throw that all into your calculator. The lateral area is 48 inches squared. Surface area, same thing, but it's just with the area of the base. So the area is just base times height. 6 times 6 is 36. Add them up, 84 inches squared. All right, so that was a pretty easy, straightforward example. Let's bump up the level of difficulty and jump to a pretty difficult. Let's do a tricky one. Here we have a 1, 2, 3, 4, 5, 6, six-sided base that is a hexagonal pyramid. They tell you the height, the distance straight down, 16 yards. They tell you the slant height, the thing that you would slide down the side of the pyramid, 20 yards. You now have to find the surface area. All right, let's look at the formula. The area of the base plus 1/2 PL. Unfortunately, the only thing we know about this is the L, the fancy L, all right, which is the 20. We don't know anything else. Let's take a look at the base. There it is. I drew it nice and flat so we can see it. It would help if we knew this piece, the apothem. If you notice in the picture, it's also this one, the distance from here to here, from the center to the side of the base. That is the same as this. All right, now why did I draw that? Because now we actually have a triangle. That side's 20, that side's 16. Use the Pythagorean theorem because this is a right triangle right here. Use the Pythagorean theorem to solve for that missing side. And it turns out to be 12, which means that side is 12. All right, so now that we know the apothem, we actually can figure out a lot of things out. We can use 1/2 apothem times perimeter to find the area of that base. Draw in our little angle, find that angle. Remember to find the central angle, it's 360 divided by 6, and then we split that up, so that's how I got the 30. You can use SOHCAHTOA or you can use special right triangles rules. 30, 60, 90 special right triangles. If you memorize those rules, to go from a 12 to this piece, all you have to do is divide by 3 with the square root of 3. And that's how I got 4 square root of 3. All right, but remember, we want the perimeter, so not only do we want this piece, we want to double it. Not only do we want to double it, we want to go all the way around to find the perimeter. And that actually gives me 48 square root of 3. It's basically 4 times 12, all the way around. All right, now a lot of you guys might use the square root of 3 button on your calculator and get a decimal. That's fine. I'm going to keep mine just like this for now. The P goes into here. The apothem, which is the 12, goes into here. And that gives us the area of the base, 288 square root of 3. That goes into here. We also did the P, the same P right here also goes into there. And then the fancy L, that was the lateral height, that goes into there. So we actually found everything we need. Okay, fill it in. Let me erase some of the arrows because that's a lot. Simplify it. What I did was I did the 1/2 times the 48 times the 20. That gives me 480. And then I just combined these two together by adding the outsides. And our final answer is 768 square root of 3 yards squared. If you use the square root of 3 on your calculator, you will get a much bigger decimal number. All right? That was pretty elaborate. I mean, you had to use our new formula for pyramid of for the pyramid. You had to use Pythagorean theorem. You had to use trigonometry. You had to use 1/2 apothem times perimeter. So that is a very advanced problem that needed a lot of knowledge to solve. So it was a good one. I like it. All right, lateral area and surface area of cones. Guess what? It's the same exact formula as a pyramid. It kind of looks like a pyramid. The cone is upside down, so now it's a pyramid. The only difference is this P right here, it's still called the perimeter of the base, but if again, you notice what is the shape of the base? It's a circle. So when we're talking about perimeter of circles, it has a different name. It is called the circumference. And their circumference of a circle has a formula on its own, 2 pi r. The L is still the lateral height, or the slant height, sorry. The slant height is the one that goes slanted. That's why it's called the slant height. And then over here, we have the big B. That's the area of the base. Again, because the base is a circle, area of the base is pi r squared. And then the 1/2 PL is the same exact thing as the lateral area. All right, let's go ahead and do some examples. We have a cone. Let's go ahead and find the surface area. This is a pretty straightforward problem. We know the area of the base is pi r squared. The r is 9. And then the perimeter is 2 pi r. And then the slant height, L, is the 15. So basically, all the information was there. You just have to put it in the calculator to get 216 pi. Now again, if you use the pi button, then you'll get a long decimal. So you can leave your answers either way, either in terms of pi or as a decimal, an approximate decimal. It all depends on how maybe the book asks for it or how the quiz or the test asks for it. Okay. Here is our last example. It's a cone. So same thing. The only difference is they do not give you the slant height, the fancy L. They give you the regular height. So when they give you the regular height and they give you the radius, we have a little triangle where we can use Pythagorean theorem to find the slant height. And I blocked it, but it is 13 if you use the Pythagorean theorem. Plug everything in, and there is our answer. All right, go ahead, try the homework, see how you guys do.